Hello students, in last class we have discussed about distance displacement, scalar vector quantity, acceleration, speed velocity, and we have discussed about formula and definition for different conditions of scalar and vector quantity, acceleration, speed velocity and distance and displacement. Now today we will represent these conditions on graph. So first we will start what are graphs. Now till class 8 you have learned or you have discussed about graphs. What are graphs? Representation of a data on two axes, that is x axis and y axis. If you represent anything on it, we can form a graph for it. In this chapter we have to discuss about two important conditions related to graphs. That is, first we have to start distance time graph and second we have to start velocity time graph. What are distance time graph? On one axis distance is represented and on one axis value for time is represented. We have to study about three important conditions of distance time graph. That is, distance time graph. If a straight line parallel to time axis is there in distance time graph, it will represent that object is at stationary position, or we can say object is at rest. That is, with the passage of time there is no change in distance. So object representing this type of graph, this type of condition, we will say it is at rest. Now, if a straight line is there between distance time graph, then it will represent uniform motion. Uniform motion of object. We have discussed about uniform and non-uniform motion. Uniform motion is a type of motion in which object covers equal distance in equal time interval. In third condition, if this type of curve is there between distance and time graph, it will represent non-uniform motion. Now again we will say what is non-uniform motion. We have discussed if an object will cover equal distance, unequal distances in equal time interval. This type of curve will represent distance time graph for non-uniform motion. So three conditions for distance time graph, that is when object is at rest, when object is in uniform motion and when object is in non-uniform motion. So directly questions can be asked to form a graph for rest, uniform motion or non-uniform motion. Second type of important graph we have to discuss here is velocity time graph. Now again, velocity time graph is a type of graph in which on one axis velocity is represented and on another axis time is represented. Now VT graph, if it is a straight line parallel to time axis, it will be observed that this graph is showing the condition of constant velocity. That is, object is moving with constant velocity. If a straight line is there between V and T, that is velocity and time, then it will represent uniformly accelerated motion. If a curve is there between velocity and time, it will represent non-uniform accelerated motion. And if an inclined plane or a straight inclined plane is represented between V and T, it will show graph for retardation or negative acceleration. That is, in numerical also we have done these conditions that brakes are applied, object is at this velocity and it comes to rest. This type of graph will represent retardation. So four important conditions in velocity time graph are of constant velocity, uniform accelerated motion, non-uniform accelerated motion and graph showing retardation. So directly questions can be asked according to graphs to show these conditions of rest, uniform motion, non-uniform motion, constant velocity, uniformly accelerated motion, non-uniformly accelerated motion and retardation. Now there are some conditions related to these graphs. We have to derive three equations of motion related to velocity time graph or by graphical method. In that we use velocity time graph to derive three equations of motion. Now two important points related to speed distance time graph and velocity time graph. First important condition is what is slope of graph. Slope of graph is the ratio of value of its in on y-axis to x-axis. Suppose if we have to find position or we have to find slope at any point on this graph, we have to find value for this axis and this axis, that is ratio of x-axis divided by the value of y-axis. If we find slope of distance time graph, then slope of distance time graph will represent speed. डिस्टेंस टाइम ग्राफ का स्लोप हमेशा हमें क्या देगा, स्पीड. इफ यू फाइंड स्लोप ऑफ वेलोसिटी टाइम ग्राफ, स्लोप ऑफ वेलोसिटी टाइम ग्राफ will always represents acceleration. That is, at any point if we have to find acceleration, ratio of values for velocity, that is what we have learned about formula for acceleration, change in velocity divided by time, that is rate of change of velocity. So this axis will represent rate of change of velocity and this axis will represent rate or time passage. So change in velocity divided by this axis, that is time, will give acceleration. So if you find slope of velocity time graph, then it will always represents acceleration. And third important condition which we also have to use in derivations of equations and numericals, if we find area under velocity time graph, then area under velocity time graph will represent displacement. That is, directly from graph or by graphical method we can find displacement. If we find area under velocity time graph, then this area is equals to displacement. So these are the three important conditions related to slope and area of distance time and velocity time graph. That is, slope of distance time graph is equals to speed, slope of velocity time graph is equals to acceleration, and area under velocity time graph is equals to displacement. And these are some of the conditions which are represented in the form of distance time graph and velocity time graph. In next video we will start with derivations of equations of motion, and for that we will use velocity time graph. That is, on one axis we will represent velocity, on one axis we will represent time. So in next class we will start with derivation of equations of motion. Thank you.